Hey, this is Mathematics Pro with Dr. Harrison. Today we're going to talk about how to use properties of logarithms to expand a logarithm. Now we have our properties over here, and we have the properties of logarithms. We're going to talk about how some of them are connected to exponential properties over here. And we'll go ahead, talk and get started. So let's start by reviewing the properties. Starting with the first one here, we have log base b of m times n, and that is equal to log base b of m plus log base b of n. That's how you read it. Now, notice that in this case, we have, when you have b to the m times b to the n, that's equal to b to the m plus n. Okay, what that means, when you're multiplying powers with the same base, keep the base and add the exponents. All right, let's take a look at this next property. If you have log base b of the quantity m divided by n, that can be rewritten as log base b of m minus log base b of n. So let's look at this exponential expression. If you are dividing powers with the same base b, right, you have b to the m divided by b to the n, that is equal to b to the m minus n. So when you have powers divided by, you're dividing powers with the same base, keep the base, and then take the exponent in the numerator and subtract the exponent in the denominator. Now let's take this one here. If you have log base b of a raised to the p power exponent, that is equal to, you take the exponent p and then multiply it by log base b of a. In this case, we have a power b to the m raised to an exponent n. When you have a power raised to another power, you keep the base and you multiply the exponents, m times n. All right? So we're going to go ahead and we'll start. I'm going to start with using this first property here. And let's go ahead and give you an equation. So let's say we have log base 2 of 11. We have log base 2 of 11. And that is raised to the 5th power. Okay, looks just like this one here. Then what you do is you take the exponent, which is 5, and then you multiply it by the log base 2 of 11. There you go. What we're doing is we are expanding the logarithm. So this is a logarithm, but this is an expanded logarithm. All right, so let's see. Let's go ahead and check this one off. All right, now let's go ahead and work on expanding a logarithm for this property here. Let's say we have log base 9 of the quantity x times y. Log base 9 of the quantity x times 9. Now you look here and you see what property applies. It's this one right here. Just as we have log base b of the quantity m times n. So I'm going to expand this logarithm. That becomes log. Let me erase that. Make that look a little better. There we go. So we got log base 9. And I might need to erase, so I'm going to erase that. Log base 9 of x. Log base 9 of x plus log there we go, base 9 of y. Okay, so we'll place a check here. Now, let's expand a logarithm using this property here. So let's say we have log base 8, log base 8 of u divided by v. I'll put that in parentheses. Sometimes they don't put the u over v in parentheses, but I'll do it in this case. So what that means is we're going to take log base 8 of u minus log base 8 of v. Okay? Nice. So we illustrated these three properties here, but now I want to get into two more problems that are a little more complex, that require more steps. All right, what we did was we expanded, used the properties in here to expand the original logarithms. And these over here on the left side, excuse me, on the right side, are the expanded form. So let's erase that. And now let's take, what if you have a case where we have log base 6 of the square root of x times y times z? Well, what we can do is we can rewrite the problem, and we can rewrite it as log base 6 of, now when you have something raised to the 1/2 power, or when you have something, the square root of a number, you can write it as x times y times z raised to the 1/2 power. Okay? Now, this looks just like this property right here, where we have log base b of a to the p. In this case, we have log base 6 of the quantity x times y to the 1/2 power. So what that means is we're going to treat it the same way, where you write p times log base b of a. In this case, we're going to write 1/2, right, times log of base 6, log base 6 times x. That's the first factor right there, where we're multiplying x times y. And remember, now we're going to write plus, same thing, 1/2 log base 6 of y, right? Looking pretty good. And then we're going to write plus 1/2 log base 6 of z. Very good. So that's how you write this original logarithm in an expanded form. And I'll just make it clear that this, all of this, right, is our final answer. This is the expanded form of this original logarithmic expression. Okay. Now we're going to do one more. This one is going to have even more steps. Okay, so let's say we have log of base 6, log base 6 rather, of, I'm going to put the quantity of x over, say, y to the 5th power times z. And I'll do that to make sure you know that that's z. And all of that is raised to the 6th power. All right. So let's look at that for a moment and examine that. Now, first thing I would want to do is simplify this logarithmic expression where we have, in this case, we have a power raised to a power, so that means we're going to multiply the exponents, okay? Now, I want you to remember that even though you do not see an exponent here, the exponent really is 1. That's z to the 1, and that's x to the 1, even though you don't see it. I'm just going to put it in there. So let's first go ahead and simplify that. Rewrite it. So we're going to get log base 6, okay? And then we have x to the 1 raised to the 6. So that becomes x to the 1 times 6, which is 6, over, here we have y to the 5th power raised to the 6th power. So that becomes y to the 5 times 6, which is equal to y to the 30th power. And then we have z to the 1st raised to the 6th power, and that becomes z to the 1 times 6, which equals z to the 6th power. All right, so we simplified this and rewrote it. Now we have log base 6 of x to the 6th over y to the 30th times z to the 6th. Now we're going to prepare and we're going to write the expanded form. Now that's simplified, but I want to write the expanded form. Okay, so if going back, let's see here. Going back here to the original problem, here, now this is just the simplified form, but going back here, if we were going to rewrite this, or as a expanded logarithm, we would write 6 times log base 6 of x. All right, that's 6 log base 6 of x. Where is that coming from? We're looking at the numerator here. So we take that exponent and multiply log base 6 of x. And we multiply that by 6. So that's the numerator. And remember, this right here, this property refers to this one here, where in this case we have log base b of m over n. And then we're going to rewrite it as log base b of m minus log base b of n. So what we did is we did the same thing, log base 6 of x, but it's raised to the 6, so we had to multiply that by 6. And then we're going to subtract. right? Now in this case, we have, look at that exponent. So that's 30 times log base 6 of what? Y, right? Very good. And we're taking this and subtracting it from that. That's right there. And then we're taking the log base 6 of x to the 6 and subtracting it from here, z to the 6. So then minus 6 times log base 6 of what? Z. All right. Looking pretty good. So this is our final expanded form of the original. So in reviewing the steps, we had to use our properties of when you have a power raised to a power and simplify this portion over here. And then we used this property to rewrite the expanded form of the original logarithmic expression. That was quite a bit, I agree. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.